Good afternoon, everybody. It is once again Ted the Speed Learner, and I'm going to continue my video series on Common Core Algebra 2 with this. But before we begin with this, I'm going to tell you some other stuff that you won't readily or easily find. Okay? Now then, one of the things that was mentioned in the Algebra 2 Common Core textbook was they have this thing called a real-world situation. Let me say that again. A real-world situation. And based on their definition, it is something that... let me try this again. It's something that has a constant rate of change. Now, for those of you who are familiar with calculus, you know exactly what I'm talking about here. I'm going to move this camera around just a bit. Give me a second here to make sure. Yep, that's good. My camera was about to fall down, folks, so that's why I had to make the adjustment. But anyway, if you are used to calculus, this leads directly into the Greek letter delta, and I will talk about that in a future video. Okay? Because remember, I told you that Algebra 2 nowadays is not the Algebra 2 that we got taught. No. This is actually Euclid, René Descartes, not a lot of calculus. There was some calculus in there, and some statistics as well. So we're going to have fun as we do this one. Alright, an absolute value is that when numbers in a domain are paired with positive numbers in a range. Okay? So that means that regardless of whether the number inside these two lines, see these two lines, these two parallel lines right here, no matter whether the number inside of there is positive or negative, that is going to be a positive number. Okay? So if we had a positive 5 in between these two parallel lines, that would be positive 5. If we had a negative 5 in between these two parallel lines, that would be a positive 5 also. So no matter whether the number is positive or negative inside the parallel lines, once you draw them out the parallel lines, that number immediately becomes positive. Okay? Now there's a reason for this. In real-world situations, there are no negative weights. Okay? You don't weigh a negative 10 pounds. You never weigh a negative 20 pounds. You never weigh a negative 30 pounds. There is no such thing as negative time. It's not like it's negative 6 o'clock in the evening or negative 7 o'clock in the evening. That never happens. Okay? Even when you have temperatures that are in the negative digits, all it means is that it's exceedingly cold. You never have a no temperature at all. Okay? You either have a hot temperature or you have a cold temperature, but you never have a no temperature at all. How about humidity? I was watching a weather service on television, and they actually had the humidity at negative 33%. That meant that humidity-wise, that meant that moisture was being sucked out of the atmosphere. Yeah, that's a little ridiculous. So that's why they have this absolute value here, because there are some things in the world that aren't negative. Alright. So what is the etymology of the word compression? Well, the word is comprimere, and that is, of course, a Latin term, which means to press together. Now then, what is the etymology of reflection? Reflectere is the Latin word which means to bend back. Okay? That's sort of like when you take a slingshot and you bend back the sling part of the slingshot. See what I mean? Or even a rubber band. When you bend a rubber band backwards, there you go. Now, what is the etymology of transformation? And all of this is very important, and you'll find out in the next couple of lessons just how important this all is. The prefix trans means across, and formare means to form. So what you're doing is you're forming something across something else. Literally, if you're talking about the word of transformare, which of course is a Latin term, you're talking about something that changes in shape. Literally a shapeshifter, if you'd like to go with that. Now, what's a translation? Okay. Obviously, the prefix trans is a cross. We just said that a minute ago. But the suffix latus means carried. Okay, so what you're doing is you're carrying something across something else. It would be sort of like if you were carrying mail, like in the Pony Express days, the guys would carry the letters across the valley from one town to the next. So that's where you get translate. Now, the actual word translatus means carried over. Okay? So to translate a graph means to carry the values of the graph across the graph. Okay? Now, what is the etymology of symmetry? Well, that's a Greek set of words. There's a Greek prefix syn, which means together, and there is a Greek suffix meaning, it's known as metron, okay, the Greek suffix metron, which actually means to measure. So, when you have symmetria, you have things that have a common measure. That's why they're called symmetry. On a parabola, and as we established in a previous lesson, this is a parabola. On a parabola, the vertex is either the lowest point on the curve, or if this was upside down, let's say it was up like this, it would be the highest point. So whether it's the lowest point or it's the highest point, that's the vertex of the parabola. Now, the vertex of a parabola is positioned on the axis of symmetry. Now, we already talked about the word symmetry, the etymology of it, earlier in this lesson. Okay? Now, what about the word congruent? That'll come up too. The prefix com means together. Then you have the root word gruere, which means to fall. So congruere means to come together, to fall together, to actually agree. Okay? The axis of symmetry divides a parabola into two congruent halves. So if we were to actually draw the axis of symmetry, which would pass through the vertex, that would mean that this half here would be equal in size to this half right here. That's what that would actually mean. Now then, let's go on with this. This is an absolute value function. Okay? And this is a transformative absolute value function. Now, if you were to look this particular equation up on the internet, no matter how many web pages you'd go to, no matter how many videos you'd watch, you would never see this exact form of the equation. You'll see a lot of it, but you won't see the whole thing. But we're going to decode this anyway because I found the various pieces. I dug them all up, and I know what all of this is. Okay. Now then, what is H and K? Well, now here we go. You have what is called a parent function, and then you have a child function. Let me say that again. You'll have a parent function, and then you'll have a child function. That's why this is called g of x, because this is not the parent function. This is the child function. So you're trying to find the vertex and all the coordinates of the child function using this. Okay. So how do you do that? Well, what are the vertex coordinates of the child function? Well, that would be h and k. H represents the x-coordinate of the child vertex. The k represents the y-coordinates the y-coordinate of the child vertex. Now then, what is the letter A and what is the letter B? Well, the letter A represents a vertical either stretch or compression. Now here's the problem with compression and stretch. If you're going to use the term compression to represent a parabola closing in on itself, then why not use the word decompression, which is actually the opposite of compression, to represent when the parabola expands, when the two rays of the parabola actually extend out. Why would you go and call it a stretch? Let's confuse the kids just a little bit more. I don't like that. But that's what they've done. They just left a whole bunch of brand new terms. They didn't relate it to old-time math. So now the kids are confused more than ever. So when these two rays start coming together, that is called a vertical or horizontal compression. Now if it's this, it's a vertical compression. If it's this right here, this here represents a horizontal compression or stretch. Okay? So this represents vertical compression. Now I'm going to say it again. This represents vertical compression or stretch, and this represents horizontal compression or stretch. So now you know how to decipher this particular equation. Now then, so where is all this leading? To a nightmare, basically. But anyway, now that you can comprehend all this, it'll make it a lot easier for you to solve your equations. This terminology is making a nightmare for kids all over the Common Core curriculum. And that's why a lot of kids are flunking. So, now that you can comprehend all this, and like I said, I've watched many YouTube videos and I have gone to many, many websites. You will not see this exact equation. You'll see parts of it, but you'll never see the whole thing. I looked. Trust me, I couldn't find it. Not the whole thing. Found several parts, but not the whole thing. So now you can read all the parts and now you know what the equation actually is. Anyway, so you say, well, what is horizontal compression? What is vertical compression? What is horizontal stretching? What is vertical stretching? I'm going to explain that in a future video, because the explanation is rather extensive and I don't want to get into it right now. But anyway, now that you know all of this, you'll have a better idea what you're dealing with, and more importantly, you'll be able to decipher your math problems. Alright. Well, this is Ted the Speed Learner signing off for this particular episode. I will tell you more in a future video, so I want you to stay tuned.